Well, hello everybody and welcome back to another project. Of course, you knew we couldn't be away from Pioneer for too long. Not sure why I keep getting so many of them, but they're just popular receivers, I guess. So this one here is a little bit unique. That's why I'm doing a video on it. It's an SX950, which is not unique, but this one I had worked on previously and did a recap and a basic restore on it, an alignment, and everything turned out perfect. I ran it for several days, worked really good, sent it back to the owner. He set it up to his system, and lo and behold, when he turned it on, the left channel would sound really weak at low volumes, and it seemed that if you turned it up, it would kind of come back in and play better. And then after it was on for a few minutes, it would heat up a little bit, and then the problem would kind of go away, but it was intermittent. So I told him to box it up and send it back, and we'll take a look at it and kind of see what it is. I have an idea of what it might be. I've seen, on these older vintage receivers, I've seen problems like this quite a few times. And there are mechanical problems that can cause this issue, and there are electronic problems that can cause this issue. Mechanically, obviously, you can have problems with the switches, but I know, I disassembled these, cleaned them very meticulously, reassembled them and tested them, and they were fine. So, I have it hooked up to a set of speakers, and I have my phone hooked up just as a little signal source. We're going to just do real simple before we take anything apart. We're just going to turn it on, and we're going to listen just to some music and listen to the channels and see if there's any kind of clue that we can find. So let's start out by let's just start up the MP3. We're set for auxiliary. I have the tone in defeat. We're on speaker A. I have volume at minimum. Let's kick it on and see what it does. And sure enough, here, that's really weak. That one's not bad. Now it's fading in. So I see what he's talking about. And let's see here. I want to get a little bit more output on the MP3 player. And when you smile for the camera, I know I love you better. Okay, so now it's working. All right, so it's really quick and it kind of goes away really fast. Let's hook up the oscilloscope and let's try putting a known equal level signal into both channels. We'll turn it off, let it cool down, and we're going to do the same test, only with a, under some little more constant test conditions, standardized test conditions. So let's do that, and I'll be right back. So here's what we've done. I went ahead and connected an equal signal, input signal, 1 volt RMS, into each of the right and left input of the auxiliary input. I've also taken channel 1 and channel 2 and superimposed them over top of one another to see, make sure that they're both putting out equal power. So what should happen is, as I raise the volume when I turn the receiver on, we should see the waveform go up. There's a 1 kilohertz signal going in there, and we should see that signal amplitude increase. And since they're increasing together, the blue and the yellow lines should always stay on top of one another like that. So the blue line should always be visible like this. If one channel has a different power level than the other, or has noise or something, then you'll see it kind of separate from channel 2. So channel 1 and channel 2 will not track unless they're equal. So let's turn this on right now, And okay, there it's on now. So as you can see, you can kind of see the yellow and the blue moving apart just a little bit. And you can see this is with the balance in the center. See how it's kind of, they're tracking pretty close. They're not exact, and that's just a function of the balance knob. The detent of the balance knob isn't exactly perfect, and that's because these resistors in these pots aren't perfect. And this is just something, you can just barely turn it, and you can see I can line them up, so that's good. But you can see right there, we're putting out, you know, there's over 50 watts a channel, and everything's tracking really well. Now, I'm going to drop the sensitivity down from ×10 to ×1, and because he said where the problem shows itself the most is at very low volume levels. So we're going to go at very low volume levels now, and just bring this up. And you can see, did you see what the yellow line did? That's the left channel. There it goes. See it? And there you have it. So there is something wrong with that left channel at low volumes. Now, let's talk about what we think that could be. And it seems like after it warms up a little bit, the problem seems to clear, and then it's happy once again. So what I'm thinking right now is at low volume levels, if there's a transistor that's not biased properly, or it has a leak in it or something, and you can see it's just starting to flutter just ever so slightly right now. There it goes. That's a transistor leakage. There's a bad transistor in there, I can tell you right now. So what I would probably do next now is, since we can get it to do this so easily, there's two different ways to tackle this. The first thing we want to do is we want to separate the power amplifier from the preamplifier section. Now, on some receivers, the best way to do it would be to plug your headphones into the headphone jack, and the headphone jack is listening to the preamp section, so you're kind of not listening to the power amp. On this amp, it's a lot easier because you can actually separate the power amp from the preamp just by pulling out those little jumper pins in the back. So what I'm going to do next under these conditions is, instead of connecting this oscilloscope to the dummy load resistors and looking at the output of the power amplifier, I'm going to go into here with, I'm just going to come right out of the preamp outputs by pulling those jumpers out, come out of the preamp outs and go straight into the oscilloscope from the preamp outs and bypass the amplifier. If we still have this same situation, then we've just ruled out half of the whole receiver. We don't even have to look at the power amp or the drivers or any of that kind of thing. We'll be right into the preamp, which is where I think the problem is. This looks very typical of those small signal transistors, and on these old receivers, this is a pretty common occurrence. This can happen. Now, you may ask, well, when you recap the receiver, why wouldn't you just go and replace all the transistors? Well, it's not really as easy as it sounds, because I'll let you guys know up front, if you don't do a lot of work with these, the modern replacement transistors that are out there for these don't always perfectly match. And it can, to replace one, you can go through a couple different kinds and find a good one that works perfectly. To just go in there and willy-nilly replace a whole set of transistors, and you get one in there that's not doing its proper job in its position, you're going to have a really, really hard time troubleshooting that and going back and fixing it. So I found that it's better to just do a good burn-in of the receiver, which I did on this, believe it or not. And if something like this fails, just replace the component that fails and maybe the adjacent component to it in the other channel, just so they're matched again, and leave it alone. Test it really well, and as long as the problem's gone, leave it go. And that's how I handle it. You know, other people may have different opinions on that, but that's kind of been my what I've had the best experience with. So let's move to our preamp outs and see if we can get this problem to reoccur that way. Alright, if you take a look here, you can see these two little jumpers that I pulled out. And all those are little horseshoe jumpers. And they are the things that jumper the preamp out to the power amp in on the rear of the receiver. Now I can just plug right into those RCA jacks to the preamp out and go straight into my scope. And now I'm only going at 100 millivolts per division. And I have my 1 kilohertz tone in there. And you can see now that I'm at 100 millivolts per division, there's a lot more noise you can see. And that's normal. That's partially the cables and all these other things. So let's turn it on. And you can see you get some DC offset in there as it is. And then it settles down once the amp kicks on. And let's turn this up just a little bit. And let's just see, after it runs for a while, if it's going to act up on us again. Now, if this acts up, we know our problem's in the preamp. If this does not act up, then we want to go back to our power amp section and see if we want to inject a signal into there and measure it coming out from there. And we can actually drive that with our signal generator into the power amp in. But let's just give this a few minutes and see if we can get it to do it. And I won't bore you to death here with running the camera. It's kind of like watching paint dry. So let me shut this off, and if it starts acting up, I'll try to get the camera on before the problem goes away. Well, now I now have the signal generator connected to the power amp in, because after a really long period of time out of the preamp out, nothing going on. So I've backed down my amplitude of my signal to about 30 millivolts RMS, which should give me a relatively small drive signal into the dummy load. I'm going to turn the amp back on, and then we're going to look and see if we get the distortion now. And if we do, we've immediately just now narrowed it to the power amp section itself. So let's turn on power and let's see what it does. And I can already see that channel flickering. Did you see it? Just coming on. Left channel once again. I have a feeling our problem is going to be in the power amp. So let's let it run for a little bit and see what it does. Once again, I'll shut the camera off here rather than have you watch here at this boring screen. I'll turn it on if we get it to act up. And there it is. You can see it. Now it's clearing out. And it does seem to only do it when it's cool. So that could possibly be one of the output transistors failing, but we don't know. It can also be one of the drivers. There's not a whole lot of components in the output section, in the power amp section of these receivers, so this should be relatively simple to troubleshoot it down to a couple of components. So let me get the cover off. Much to my surprise, I would have put money on that it was going to be in the preamp, because those little preamp transistors fail a lot in there. But it's on the power amp. So let me get some covers off. Let's get inside there and do a couple more tests and see if we can narrow it down even closer. Now I got the cover off of the receiver, and I'll just show you real quick. You can see I just have, right here's the section we're interested in. From this, let me back up, from this part right here over is the left channel. So just this little section here is where everything's happening. So what I'm going to do is I'm going to go in and I'm going to kind of like tap around on a few things like this with this thing on to see if that affects it. See if maybe, you know, a resistor or something like that, it has a mechanical failure in it. And then if that's not the case, then I'm going to go around and kind of feel these transistors. And don't worry, there's no real high voltages in here. You could get a little buzz off of it, but it's not super dangerous. Again, you're doing so at your own risk if you work on these types of things. But I'm just going to kind of check around. These resistors here are your actual current limiting resistors, and if one of them gets hot, then that means one of the transistors is actually overheating, which probably is an indication that one of them is bad. This does have its original Hitachi transistors, which were very, very good sounding transistors. They were known for their good performance, but they can fail. They usually don't, especially on really low hour units like this one, but it does happen. And if that's the case, we'll put new transistors in. But let's poke around and see if we can get it narrowed down just this way. So I'm going to zoom you back in so you can see if we can get it to do it. And if it is doing it, we'll try poking around a little bit. So it's doing it right now. I'm just seeing if I can make it worse or better. Okay, so it's not the bias or balance pots because I'm tapping on them pretty good. It doesn't seem to be doing anything. I'm now checking the resistors, and none of them are getting warm as of yet. Let's see here. None of the driver transistors seem to be bad. They're all running nice and cool. So that's actually a good thing. And there's two little small signal transistors, and if I were a betting man, I would say those are the ones that are going to be the problems. Let me see if I can get a can of freeze spray, because it seems to do it the most when it's cooled down. And then we're going to chill these couple transistors and see if it'll do it. Okay, now the right channel's going crazy. Take a look at that. It's just bouncing up and down all over the place. So, and it actually kicked out the relay here before I could get the camera on, and then the relay kicked back on. It's actually getting some DC on it. And I don't feel anything. Up, there it goes. There goes the left. Okay, let's see if we can find it. Straightened it right out. It is those little transistors. Okay, I'll show you what I did. If you look right down here on these two little transistors, all I did was took some freeze spray and just gave it a little shot, and it stopped the problem right away. So I'm not sure why the right channel did that. It only did it one quick time, but I have a feeling those small signal transistors are, or at least one of them is bad. So what I will do, since they're very inexpensive and I have them in stock, yeah, look at it. It's doing it again. You can see. I'll put a little more spray on it. And you can see it straightens right out. So we've got some bad transistors, and that pretty much proves it. So the first thing the next thing we can do now is we can actually look at the voltages on those transistors with a meter to be double sure. And if we see the voltage going all over the place, then we can be very, very confident that it's those transistors. But I could almost just shotgun it right now and replace them, because I can tell you with that freeze spray, that's proving those are bad. But what the heck, this is a video. Let's take it one little step further. Well, I think we found our culprit. If you look down in here, I'll try to stay where you can see in the camera. You have this transistor and this transistor. As soon as it was doing it pretty bad there, and I just touched my probe on here to check the voltage, which this is your 50 volts input on the collector side of this NPN transistor. As soon as I touched it on there and kind of moved things around, it locked right in. The amplitude went perfect, the noise went away, and the amp has been working perfectly ever since. So I think we have a faulty transistor right here, this one. So what I'm going to do, now that I'm pretty confident that that's what it is I'm going to, these are 2SA726s, I believe. Yes, 2SA726, and there's two of them. They're both 2SA726s. So I'm going to find a good equivalent, and I'm sure I know I have these in stock. And I'm going to go ahead and not only replace these two, but I will replace the two on the other channel as well, just for good measure. Then hook it all back up, thoroughly test it, because once again, like I said, whenever you replace these transistors, these old 2SAs, with some of the modern modern semiconductors that are out there, you always run the risk of the gain or some factor of the transistor being slightly different, causing you some problems, and they won't work. So you really have to test it very thoroughly after replacing them like that. So that's what I'm going to do right now. I'll get these replaced, put it back together, and we'll see where we go from there. So hang in there, and we'll be right back. Okay, we've got the two transistors replaced, and actually I did the other two over here as well, and I kind of put them up on the transistor checker and matched them to make sure that we have two match sets. So everything looks good. So now all there is to do is I have the signal generator hooked back up, got the scope hooked back up. So let's move over here and change our view and turn it on and see what it does. Alright, here we go. Flame on. Look at that. Perfectly balanced. Looking good. Okay, what I'm going to do now is I'm going to turn down the input a little bit, and I just want to make sure that this thing tracks very low. Alright. Low volume, because that's where we were seeing most of the issue. And as you can see, it still looks pretty good. Alright, so let me go up a little bit. Let's see here. I'm going to take this up. Okay. Tracking very nice. Alright, I would say we have this fixed. Now, what we're going to do now is we're going to let this thing sit at kind of a low power. We're going to move our input back down to where it was acting up the most, like that, and I'm going to just sit here and let it cook for maybe about 20 minutes or so. And this is real low power, as you can see, but that's where it was showing at the worst, was at lower volumes. And we're just going to let it do its thing and see what happens, and we'll be back. So here's where we are so far. We started out with the amplifier running at about 100 milliwatts per channel. I ran that for about 15 minutes, absolutely no problems. It ran perfectly. We're now sitting at 60 watts per channel. And remember, this is like an 80 or 85 watt per channel receiver, so it's running pretty high in its power range right now. And we're coming right up on 20 minutes of continuous 60 watts per channel. So let's move over here, and I'm just checking the heat sink, and we'll see what kind of temperatures. So 110 Fahrenheit there, 107. I'm just checking the tops of the 4 banks. Okay, and for you Celsius people, we're looking at around 40 degrees centigrade, between 40 and 45, and that's very, very acceptable considering this thing's been running at full power for, I mean, I can keep my hand on it, but it is getting warm. So, but everything's looking pretty good right now. So I would have to think that that we're going to be okay. And again, all right. So there you have it. I'm going to turn this down a little bit now that we've got it, because my resistors are starting to get pretty hot too. Yeah, my dummy load over here is getting pretty hot. Let's check how hot the dummy load is. So that's 120 watts going into there. 25C. Well, that's not too bad. 81 degrees Fahrenheit. So, not bad. Well, 300 watt resistors. So, I'm thinking that this was a success. And I think it's all fixed. Everything looks good. Here's your culprits right here. Well, actually one of them, at least, was acting up. So I just replaced all 4. And again, these are PNP transistors. They're 2SA, what's that say on there? 2SA726. And there are different substitutes you can use for those. They make a KSA726, which works really well. A 2N5551 will work in these really well with no problems. Of course, you have the old NTE substitutes and so forth. But anyhow, the biggest thing is in that position there in the amp, if you replace them, replace the pair, and try to use a matched set. So if you don't have a transistor curve tracer, at least use one of these little $10 component checker things, and you could throw this. Let me see if I can do this real quick for you. You can throw this in here, and I mean, it won't be the world's most perfect test, but you can do that and it'll show you what the gain is and so forth, what the forward voltage drop is on it and so forth, and just try to get a couple that match up similarly with these specs. I just found that you get a little bit better, especially at the low volume levels. When you listen at low volumes, you get a little bit better performance if they're matched. If they're not, even if they're not matched, it'll certainly work. It won't necessarily break anything, but at lower volume levels, I like to have it a little bit matched if we can do that. So anyhow, that's the repair there. This one wasn't too bad to do, and I have a ton of stuff coming in, lots of work coming across the bench. I have kits to build, so we got all kinds of excitement coming on here. And so I'm going to wrap this one up and get it back to the owner. And as always, I wish you all peace, health, joy, and happiness in your lives. And we'll see you next time. And until then, Merry Christmas. And you guys have a wonderful, wonderful week. Thank you. Bye-bye.